So chapter 2 of our textbook is dedicated to atoms. And what I've got in the worksheet is a couple links to YouTube videos which will, I think, give you, they're not, you're not obligated to look at them, but I think they're give you sort of an interesting view of the technology that's described in chapter 2. The main point of chapter 2 really is to talk about atoms. So Tro makes the claim on page 43 that if you want to understand matter, you have to begin by studying atoms. And we know from page 5, chapter 1, Dalton's atomic theory, matter is composed of small indestructible particles called atoms. Okay, so we know that atoms are small, but how small are they? To give us an appreciation of how small they are, we don't give actually numbers here. Tro doesn't give actual numbers, but to give an appreciation that he describes a technology called STM, scanning tunneling microscopy. And he describes on page 44 how scanning tunneling microscopy works by saying that STM works by moving an extremely sharp electrode. Let me give you the figure for that. It works by moving an extremely sharp electrode. This is atomic sharp right here. Look at that. These are all pictures of what an atom, they represent an atom. Atoms aren't exactly perfectly spherical like that, and neither are they do they have shells like that, but it's a decent way to think of it. So you might have an electrode which is extremely sharp, like 1 atom thick. Do you see the atom right there? 1 atom thick at the tip. STM works by moving an extremely sharp electrode that is a conductor through which electricity can enter or leave over a surface and measuring the resulting tunneling current. The electrical current that flows between the tip of the electrode, that's this right here, this is the tunneling current. The tunneling current, that is the electrical current that flows between the tip of the electrode and the surface, even though the two are not technically in contact. All right, so as this moves across the surface, you see how there's another layer right here. That is, if this is going in this direction, as it goes across there, it's going to come to a bump, right? Well, that distance is going to decrease a good bit. And so in order to keep the current constant, this tip will get moved up a little bit by some apparatus. It looks kind of like this. Extremely, extremely sensitive. And so that's what STM is. And again, I would encourage you to go and look at the videos that the links of which are at the top of the worksheet for Chapter 2, Section 1.